good students, SS1. Remember, in our last lesson we discussed crystal structure. We were able to define or differentiate between crystal and the non-crystalline substance. We got amorphous substance. We were able to give examples, define crystal, define crystalline, say the properties of crystal, properties of amorphous, the differences, simple, relative, cubic, base, and the phase center. So we provide that note. Today we're going to move to our next topic, which is photons. Photons, what is photon? What is a photon? Photon is, before I describe it, when you are hungry and you want to eat, maybe a plate of rice, no matter how hungry you are, you can never put that plate of rice inside your mouth at the same time. You have to use spoon to take it one by one until you finish the whole plate. Or you are tasting and given a cup of water, you cannot pour the water inside your mouth at the same time. You must take it bit by bit, as your mouth can accommodate and swallow. In the same way, energy of particles are not absorbed continuously, even absorbed bit by bit in a small packet called quanta. This idea was covered by a man called Planck. You know more about it when you go to quantum physics. Before 1902, all the knowledge of physics was derived from classical physics. Until classical physics broke down, cannot regard certain behaviors in matter. So that is the idea of quantum physics. So that quantum of energy is also called photon. So we're going to discuss photon. Now, photon is just quantum of energy. You have to quantize the rice when you're eating it, or you quantize the drink you are drinking, or even fufu. When you want to eat fufu, you get it into a ball based on your throat. So photon, I was the board. Photon is a discrete bundle of electromagnetic or light electromagnetic energy or light energy, which are in motion, in a vacuum. The way remember you talk about the magnetic, you talk about vacuum. So instead of photon in the discrete, the idea, see what I want, discrete. That's a particular value, discrete. So bundle of electromagnetic energy or light energy, which are in motion in a vacuum. That's what we call photon. I told you, call it quanta of light. It has the following behavior. Number one, it has what they call Compton effect. We are going to meet photon in your SS1. So we are discussing it, you use spiral approach in physics. We are doing it for SS1. So Compton effect is something you're supposed to know. But for this level, what you need is properties of photon. It has what they call the Compton effect. You have photoelectric effect. Photoelectric effect. Behavior. You have what they call black body radiation. Black body radiation. In fact, this is where the classical physics break down. Break down. That when an atom transits, instead of getting a particular light or color, you get series of colors. They're like a chameleon. So it changes based on the environment. So this is why the Planck and co started asking why. Before they discovered that light is being absorbed not as a whole, but in small packets. Then they have also emission and absorption. Emission and absorption of light. Finally, it has momentum and energy. And momentum and energy. So these are the properties of photon. Then this behavior is used to explain particulate nature of light. Particulate nature of light. They may ask you, BJ, which of the following explains particulate nature of light? What I mean, that the light as a particle. Which of the following behavior of light prove that light is a particle? Here are the behavior. Or matter. When either you say light or say matter, but matter and light, they are the same thing. So this will lead us to a topic in physics, SS1 topic, which we are going to hear now, and you know it more in SS1. What they call duality of matter. Duality of matter. Duality of matter or light or wave particle paradox. Wave particle paradox. So when you hear this, they actually explain that. What does that mean? When you say dual, dual means two behavior. Dual behavior. So we say how dual character. You have to explain. That's a complex explanation. Maybe you can carry Bible, sing praises to God, and after that, in the evening, you can carry gun and go and steal. So you see how dual character. So dual behavior of matter. But you should know that you can never carry Bible at the same time, carrying gun at the same arena. After this, you do the other one. So here, this means that matter or light behaves as a wave or as a particle, not an matter or wave, matter or light, I mean, behaves as a wave or as a particle, but not as both at the same time. If you remove all here, this all is very powerful. If you put and here, to call it zero. If you say matter, up here. If you say matter or light behave as a wave, and here, and as a particle, that and has spoiled the whole thing. You may cook a very good soup, and then you put the last salt. The whole soup will be nonsense. So that's all. If you move and put and the score is 0, because it can never happen at the same time. It is the behavior of matter as a particle that we call particulate nature of matter, and this is the behavior. Let us now see the behavior of matter as a wave. As a wave, matter or light has the following behavior. Number 1, reflection, refraction, interference, diffraction, and depolarization. So matter or light can behave like that way, and this is the wave behavior. This is the wave behavior. This is the wave behavior. So if I ask you a question to give me the behavior or the examples or behavior of matter as a wave, you can do that. As a particle, you can do that also. Then the next I will discuss is energy of photon. This is where I'm going to do some calculation. Energy of photon. Remember I told you photon has a particular amount of energy. Quanta of energy. Quanta of rice. Quanta of water. Small. You know, the size of I don't know my own kids, but I know that the man normally swallow a very big size of fufu, but women swallow a small one. I don't know whether their throat is smaller than that of man or they are not hungry. But the size depends on you. Depends on you. You have to do the size you're going to be able to swallow. So quanta of fufu, that's the quanta, that's small packet, that's small. That energy is equal to H. I will help here for you. When you go up, I can now use H small HV. F and V means what? Means the same. E stands for energy. Is equal to energy. H is Planck constant. H is Planck constant. That is, we are in science. In science, what the whites need in science is to immortalize their name, not to give them money. But we Africans, we want money. So because of Planck discovered this, his name is associated with that. You can talk about Ohm's law, Hooke's law, and others. Where F is equal to frequency. This equation can also be written like this. E is equal to HC over lambda. Because, you know, in classical physics, V is equal to F lambda, which means that F is equal to V over lambda. But V are here. V in quantum physics is C. That's the speed of light. In classical we call V, in quantum we call C. So from here, C, speed of light, and lambda is wavelength. Without wasting time, let us see how we can now use to solve problem now. And that will tell us the end of the lesson. You calculate. You know, in physics, you don't talk too much. What you need is calculation. So you have to be good in calculating. Question frequency says, calculate. Question number 1. Say, calculate. Calculate the energy. The energy contains in a light, the light photon of frequency frequency 8.57 times 10 to the power 14 Hz. Take hash equals 6.62 times 10 to the power negative 34 joule second. They will give you this, it's a constant. They will give you that. How do you solve this? Important solution? E H HF. Finish. What is the hash? 6.62 times 10 to the power negative 34 multiplied by frequency is 8.57 10 to the power 14. I don't know how many of you can handle this in calculator. That's another thing. You have to learn it. Point 6.62. This is not multiplication. This is exponent in your calculator. Sometimes you may see 10 to the power x. So this is not multiply. This is exponent. You point exponent. When you point it, you will see where they put something of this nature in your calculator. Or some will put it like this. Press it, that will give you minus 34. Multiply by the same thing. 8.5 exponent 14. You work it out. So when you work it out, you arrive at this answer 5.682 multiplied by 10 to the power minus 19 joule. That is the energy required. Energy required. In SS1, you are familiar with scientific calculator. Question number 2 says a light photon of energy 3.96 times 10 to the power negative 19 joule falls on the metal surface. Stop. Calculate one photon frequency. Number 2, photon wavelength. Take hash equals 6.63 times 10 to the power negative 34 joule second, and C equals 3 times 10 to the power 8 meter per second. You see, you look at it here, I use 6.63. Here I use 6.62. So please, don't assume you have known the constant. Use the one that's given you by the WAEC. And I'm telling you that this topic we are calculating is SS3 topic, which we are doing part of it in SS1. So when you reach SS3, you won't bother yourself again. I told you that almost 80% of what you see in the WAEC and NECO is SS3. It's SS1, SS2. Well, SS3 may or less just to a revision. There's no particular cost outline for SS3. Yeah? So you have to be very prepared. Now, pick your calculator again, solution. If you look at that one, you are given frequency to find energy. You are given energy to find frequency. You put down the formula, HF, here F is equal to E over H. What is E now? E is 3.96 times 10 to the power negative 19 all over what is H? 6.63 times 10 to the power negative 34. Pick it up like as I told you. 3.96 exponent minus 19. That minus, that one get plus, plus and minus you see. But that minus, they will put it like this and maybe circle it. Yeah? Search for it, you will see it. And the exponent is something like this. Or 10 to the power x. My own calculator say 10 to the power x. Use it and you solve the problem. When you solve the problem, you arrive at this answer 5.97 times 10 to the power 14. If you leave it like this, half mark is removed immediately. You must say haze. You must say haze. Sometimes you say we are wicked or we don't give marks, but I'm telling you that without unit in physics, what you are saying is meaningless. For example, someone asks you, how old are you? It's not 10 naira. That naira there will make the answer meaningless. Someone will do that if you are mad yourself. So you need to now tell us where you are going and what you have in mind. So don't joke with the unit. They said again, find the photon wavelength. You go to the second equation. E is equal to is there HC C over lambda, which means that lambda is equal to HC over E. What is H? 6.63 times 10 to the power negative 34. Multiplied by C. C is 3 times 10 to the power 8. All over, what is E? E is 3.96 times 10 to the power negative 19. Yeah, this is another place to have problem in calculation. Sometimes you may say this times this divided by this. What you divided is this over this. So you better you finish solving the upper, the numerator, keep, and then divide by denominator. Don't tell me this explain this times this divided by this. No. You must say this times this equals divided by this. That is sometimes I want to be very fast. And it is very, very painful that you know a particular number and you fail it out of your carelessness. Very, very painful. So that will give you okay, I will give it to you. I'll try to solve it as an assignment. As an assignment, I won't give it answer now because it's not repeating you. Just multiply this and divide by this. You get it. Then I will stop it here. But before I stop, let me do a kind of closure. Remember what I said about photon? What you need here in this topic is define photon. Know what a photon is? Give us the properties of photon. The particle properties and wave properties. Then define duality of matter. Define duality of matter. Then use Planck equation to solve any of the following. Find any of the following: energy of the photon, frequency of the photon, wavelength of the photon. When they are giving you the Planck constant and speed of light. Next lesson, I move on with you. I'll give that topic in advance. Fluid at rest and in motion, surface tension and the viscosity. So if I were you, I will try to read text books, different text books, prepare yourself for the lesson so that when I start teaching, you will follow it. Remember that if you have not treated, you will not be repeated when the school reopens. And the school will be very, they are about to be reopened. So So you cannot stay at home forever. COVID-19, whether it goes or not, school must be open one day. And the first year academic exercise. Thank you and God bless.